So again, my name is Matt Danny Mohawk. Matt, really just here to introduce these fine individuals because they're the ones you're here for, not me. You can find me anywhere, any old day of the week. We're gonna have a great conversation. I say they are gonna have a great conversation and talk to you about compliance 101 and compliance automation, what that means, how you can use it, and hopefully maybe how you can use them and their skill sets and things they have to offer. And as Rob Slaughter says, I'll just throw a quick plug. We have an end of day survey or end of session survey. We just threw it in there. I'll throw it again after the session. We want your feedback. Everything you guys are letting us know helps us make this better for next time, and also make sure that we get you in contact with any of the speakers that you want to talk to afterwards. So please fill that out. Thank you. Without further ado, I'm going to introduce the wonderful Brandt, Keller, and Dr. Michaela Iorga. The stage is yours.
Thank you. Thank you so much, Matt. Good afternoon, everyone. And thank you for joining us today, our session. I have here next to me a friend, a good friend, and a collaborator is Brandt Keller from Defense Unicorn. Thank you for inviting me to co-present the session. The session is entitled Compliance 101 and Compliance Automation. And the reason for the title is actually not because we'd like to insult the audience that they don't know what compliance is. In educational system, 101 means you know nothing, will tell you the basic of that. It's basically we want to share with you, and Brad more than anybody, to share ways of automating the compliance to make that easy. I'm Michaela Iorga. I'm the OSCAL Strategic Director at NIST, National Institute of Standards and Technologies. That's one of my hats that I carry. I do have multiple hats. I'm also I'm serving as the Senior Security Technical Lead for Cloud Security and Cloud Forensic. I chair several working groups. The most recent one is on multi-cloud security. If you are interested in this kind of interesting research, please join us. Brad, would you like to say something about yourself?
Absolutely. Thanks, Michaela. So I'm Brandt Keller. I'm a software engineer at Defense Unicorns. And really a lot of the work that I do is centered around platform engineering. I have a background in military and then the defense industrial base. And so really trying to bring that experience to the table and, kind of find ways where, what things do we dislike doing? What things, for lack of a better word, suck and need to be made better? And so my passions really revolve around identifying these and building out, different tools to assist in that ecosystem, as well as generically just open source. Sharing of information is huge, as well as building out tools in the open source, contributing, maintaining, and just getting to be a part of those ecosystems really fosters a lot of shared education, shared informance of what's going on around us, and how we can adapt to kind of the changing landscape, which is a big topic for cloud native. So with that, Michaela, I think we can get started.
Yes, thank you. If you don't mind to advance the slides. So Greg and I decided to put the deck together. We looked and tried to clarify a little bit the concepts, just to see the conversation. We'll put in this slide what compliance is, which is the act of conforming to a set of standards, regulations, or requirements. And you can look at regulatory compliance and corporate compliance. But you also have the risk management that is defined as the process of identifying, assessing, and managing potential threats that could damage the organization's reputation. Despite the difference between compliance and risk management, the risk management technology can actually address both. And in the world I'm coming from, we work a risk management process as part of the compliance. So if FISMA requires from us to meet particular standards, regulatory requirements, we do that, and it points to us that is we have in the process to manage the risk. This is our responsibility to be compliant and to manage the risk. So I won't stay further on this slide, and I would like, if you don't mind, to advance the slide, try to demonstrate to you how to not feel adverse towards compliance and accept it and embed in the process a risk management approach to minimize the risk to a residual level that is acceptable for your organization. So you all know, that's the reason why we're here today, that the information technology is very complex. We know that regulatory frameworks are actually burdensome, and paper-based assessment and authorization really does not scale. It's a nightmare, it's error-prone, it's laborious, and it's very difficult. All those, if you think and look at the bigger picture, can be addressed, and they all call for automation. Security vulnerability are everywhere, so how else other than continuously updating the information and employing automation processes you can address those? And then risk management is extraordinarily hard. So again, address those. It means that we need to have automation. In the past decade, we moved more and more to cloud solutions. The cloud services and the solutions became more complex, and we aim to employ, and that's the reason why we're here, DevSec operations and infrastructure as code. But they are extremely hard in multi-cloud environments. And as I mentioned earlier, if you're interested on diving deeper into the topic, please come forward, contact me, and I'll help you to join our research that we're doing as part of the multi-cloud security public working group. So we all understand how important it is to provide interoperability, to have standardization around automation. If you go to the next slide, please. Years back when we were developing, or when we were working with do-it-yourself IT system, it was in a way easier to address the security requirements, because we were able to have clear visibility into the entire stack, to wrap the arms around the entire system, if you want to say. But we moved towards a more convenient cloud service. And with that migration, more and more of the services of the systems to cloud services, we were faced with, especially in the government space, with the confusion, I would say, at the very beginning of where and who is responsible to demonstrate, who is responsible for that compliance, and how to mitigate the risk. We are referring at the beginning of the entire cloud architecture as the iceberg architecture, simply because the customers had very little visibility, and the cloud service providers had the entire infrastructure that they were managing. So having the need to understand how the data is secured, since the compliance, the FISMA was making, is still responsible for your data and for the security of the entire system, it was extremely challenging. So the key to addressing the solution was not every single customer to have visibility all the way to the bottom to this iceberg, but rather to have the iceberg being transparent, providing the necessary information in a way that is not putting in any jeopardy the security of the. So automation was what NIST was looking at and found as being the solution, the key to the problem. Next, please. So about 5 years ago, we decided that we need to establish a cyber machine readable Esperanto, if you want, that a language that allows to express the security information at all levels in the stack, that enables actors and tools and organizations to exchange information via automation. So OSCAL set the foundation for the automation and interoperability. I put earlier in the chat the link to the NIST page of OSCAL. OSCAL stands for Open Security Controls Assessment Language. Next, please. So what is OSCAL? OSCAL is the result of NIST and FedRAMP collaboration and provides a common and a single machine readable language expressed in 3 formats, in XML, in JSON, and in YAML, for multiple compliance and risk management frameworks, something like, a way of representing in the same language the SP 853 or the ISO IEC 27001 or 2 and COBIT or PCI requirements. We wanted and we aim to provide through OSCAL a means of software and service providers to express the implementation guidance against the security controls. And we wanted to be able to share some security controls implementation for the systems that we own in machine readable format. We wanted to share assessment plans and assessment results. But more than anything, we want OSCAL to enable automated traceability from the selection of the security controls through the implementation and assessment. I still remember some of the paper-based approaches that we were employing, where you have a huge hundreds of pages, if not more, of Word documents that are taking every single control that the system is supposed to implement and is describing there in human language, accessible, how the system is implementing the controls, in allowing in the process for a lot of interpretation in my view, because it was not always very clear when a system owner would document it that the assessor is going to understand that information the same way. So we structure OSCAL in 3 layers. So we have a control layer, we have an implementation layer, and an assessment layer. In the control layer, we have 2 models. We have an OSCAL catalog model that it can be used to represent controls, and we have an OSCAL profile model that can be used to represent baselines or selection of controls and support tailoring. We have in the implementation layer, then we have 2 models, the system security plan model and the model that we refer to as component definition model. And the assessment layer has 3 models, the OSCAL assessment plan model, the OSCAL assessment results model, and the OSCAL plan of actions and milestones. So in this slide, I'm also trying to capture graphically the fact that information is not repeated and the traceability is provided through linking of the data in a way that allows you to, if you have one update, to be able to propagate that update into the entire stack of information, and to show also the alignment. If we go to the next slide. This slide is trying to depict for you the models with a very high level graphic representation of the assemblies. We refer to them as OSCAL assemblies, the type of data that can be captured in machine readable format in those models. One very important thing that we address with OSCAL is the fact that every single piece of information there, not just at the assembly level, but at very detailed level, it has a unique identifier. So if I'm looking at a control catalogs, I can point very clearly either to a full control or to a guidance of the control or to a simple statement in the control with a unique identifier. And that unique identifier allows me to trace that information in the entire stack and be able to address it, be able to modify it, to tailor it into a profile, to be able to point to that and demonstrate in component definition how I'm going to implement in this component that control, how that control is satisfied, or in the system security plan, how the control is satisfied, or how am I going to assess it. So This is absolutely crucial for what Brandt is going to show to you later in this presentation. Coming back to what the models are, so we do have the, as I mentioned, the catalog model that can be used to represent catalogs like 853, ISO 27002, COBIT. Those are the ones that we already tested. I am very happy to share that ISO is very seriously talking about representing their information in OSCAL using the catalog model, the 27002, that cost has it ready, the CCM version 4, that CIS has also their benchmark, the version 8 in OSCAL, and many other entities. The profile model is used to, and allows you to select controls from the catalog to create your own subset of controls. The baselines is one example, or to take controls from different catalogs and create your own profile or baseline and modify, tailor the controls. You can, this model is used for NIST, for example, to publish the baselines, the 853 Bravo, by FedRAMP to publish the FedRAMP baselines, by organizations to create their own proprietary profiles. Then in the implementation layer, the models in green here, we had to do better than we used to do in the governance space before. So we had to allow for decomposition of the systems into small components to be able to assess them separately, to be able to document every single component of your system. What are the controls that is implementing, or what are the controls that is satisfying for that system if that component exists within the system, and to be able to leverage in the process as a system owner information that can come from a vendor that can document using a component definition how their product, how their software is satisfying the controls. What are the controls that are satisfied and how they are satisfied? And add additional security information when necessary. And then this information that is generated in machine readable format can be used and imported by assessors to generate the assessment plan, which captures all the actions that are necessary to the planning of the assessment of the system. And here is also where we have innovation, because we allow through the assessment able to capture snapshots in time. So you don't have to do the entire system at once. And that's done with intention to be able to support automation. The same way the assessment results model is used to capture the real assessment, the activities, allowing to document additional findings, to capture all the observations, to identify the risk, and then to take those, pack them, move them into a plan of actions and milestones that is aligned with, because it's important in a system security plan, and convey that information, all the risks and the findings, back to the system owner to address it, to address them or to assume the risk. If they don't want to address the findings, they don't want to mitigate the risks, then they have to assume the risk, but they have to be aware of this information with as much granularity as possible. This is key to the entire process to do better overall. If we go next. So the first release of OSCAL NIST released OSCAL 1.0 in June 2021. Can you advance the slides, Brad? Thank you. Here I go. And we included in the slide a QR code that will help you, that will take you straight to that release. Since June 2021, we released 4 patches. People started adopting OSCAL extensively. Today, OSCAL is adopted internationally, and I'm very proud to say so. We are very all entities operating in regimes. In the slide that Brad has shared with you, this is our website, and you can find a lot. One that I like the most and I'd like to bring to your attention is basically the documentation that we have. So please look for outlines that will provide sort of a map that you can expand with all the structures, all the assemblies that you have in every single model. And in the next slide that Brad is going to advance soon, we try to capture that to give you an overall picture of what will be the actors. What are the actors that can capture those? Here we go. This is the slide that I was referring to. There is so on top of the slide, we capture all different type of actors that can use different models. And at the bottom of the slide, we decompose the risk management framework steps. And for every single step in there, we try to identify the type of OSCAL content, the type of information that can be used, and what will be the model, of course, that will have to rule the formatting of that information, and how to use that. So how you can prepare, how you can theorize and select the controls that you need, how you are going to implement them, and then the assessment part that you have in there. You end up with an authorization to operate, but you want to continuously maintain that. And you are also mandatory as part of the risk management framework under the compliance regime, under requirements coming from FISMA, to continuously monitor your system. So the same type of information, the same models can be used to document how you are your continuous monitoring of the system, and to convey the information, the findings back to the system owner to address, to create the proper process in place, the proper automation process in place for a continuous authorization to operate. Next, please. Before I pass on the microphone to Brad, go one more, please. I would like to highlight for the audience out there that might still have a little bit of confusion. If we go to the next slide, please. What are we actually dealing with? Not once we're going over the models and present that, diagram with all the models there, and then the first question is, that's fantastic. Where is this OSCAL tool that I can download and use? Well, NIST is developing the OSCAL models, and you can think of the OSCAL models for the ones that are not really developers, probably very few that are here in the audience, as grammar, like English grammar. And then you use that to generate OSCAL content, to write your essay. But you're not going to have to use some tools. So you need some OSCAL editorial tools, and you can choose there when you write your essay. I'm going to write it in words, or I'm using Microsoft Word, or I'm going to use simple text, plain text. You generate it. You generate information in machine readable format using editorial tools, but then this information gets consumed by GRC tools that speak the language. The biggest advantage of having a GRC tool that speaks the language, the fact that you can throw at that GRC tool any information in OSCAL, because the GRC tools know the language, will know what to do with that, will know how to process it, and you are not locked. You have by default interoperability once you are using GRC tools that speak standardized languages and not proprietary solutions. In the next slide, I just provided an example for the audience, and I'm hoping that this provides enough background to see the conversation, and I'm ready to pass on the microphone to Brad.
All right, thanks, Michaela. So I'm going to dive into compliance automation. It's kind of self-explanatory at first glance, right? We're automating compliance. But really, this is kind of a large space for, innovation and solutions to start really build up this ecosystem of what can be done with OSCAL. There is a bunch of work that already has been done. I don't want to disclude that from the conversation, but it definitely takes an ecosystem to start building out what are the gaps. What is it that we're working with, and then what is it that we'd like to see optimally in our systems? And so what I'm going to talk to is kind of like high level, how does this work? What should we be thinking about? And where can anybody really start to introduce value into the stream of automation for compliance and above that, security, right? We're getting at the security of our systems. And so we're going to lay some groundwork, right? We're talking about like, what is compliance automation, automating these manual tasks, such as risk assessments, alerts, notification, right? We're streamlining compliance workflows and reducing process redundancy. And really what I want to do, or what I do want to do, is break that up a little bit, right? We want to automate the manual. That's pretty straightforward, well understood. Manual tasks, they take time. And every time you need to revalidate those manual tasks, you need to have somebody go and conduct that activity. And it takes time, it takes people away from other activities. And so what we want to do is then like look at, okay, well, we want to automate, we want to then streamline compliance workflows. How can we get to ATO faster and continuous authority to operate, not only faster, but more reliably with better assurance, reproducibly validating compliance for this continuous authorization is very important. And I'm going to get to kind of continuous compliance later in the slides, but then kind of moving on to redundancy. And this is where I think automating the manual, redundancy, I think they really kind of coincide together. But if we're talking about those manual tasks and we're talking about where people spend their time, we don't want people spending their time doing these repetitive processes of, I'm going to go check and make sure this control is validated. And then whenever the periodic check needs to be conducted again, they go and do that check again. It takes time, and it removes people away from the ability to continue working on, in necessity, innovation, right? We're going to, with automation, we're going to start talking about shifting people around and saying, okay, let's work on automating, and every little bit of automation builds upon this stack of automation that can be had and can really enable people to continue spending their time on better activities. And so really, like, the real question that some may have is why? Why should we be doing this? And it's to get away from this phrase, we've always done it this way. We want to iterate on this problem space. And so we'll have seasoned veterans in compliance who are challenging automation. And this is really good. We want people to challenge our understanding of how to do something because it builds higher fidelity compliance. It builds higher fidelity automation. And the gap here is, as I see it, and as others kind of have kind of discussed, is there's not a lot of data supporting the development of a lot of these control validations, et cetera, in the open. And OSCAL is definitely an activity that is trying to work against that and to assist. But these were previously done in some sort of silo. And so we want to get towards, publishing things in the open and understanding, not saying this is how my system's secured, but saying like, here is how some stack of software, some application provides me with an inheritance model for how a control is satisfied. And I think OSCAL, the component definition, the ability for software providers to state kind of that relationship is going to be crucial in how we're going to move forward. So we're not only discussing automation, but we're really talking about like, the models for control validation, making that public, documenting how a certain piece of software validates a control against a standard by those who are most informed, i.e. really the software developer that builds that software is likely the most informed about the intricacies of how the networking works and how the storage works and some of these other details, so that they can provide that information in a way that consumers can kind of inherit and take and run with. And so we've mentioned it before, like what we're really getting at here is risk management and security, compliance validation. Really, we're validating that these systems are secure. And so we want to lean into that reduction of redundancy of these redundant processes. We're freeing people up to focus on that higher fidelity validation. And, you know, if we look at historical models of how this may have been done in places previously, and we talked about having that person who is going and conducting each activity manually, and that's perfectly fine. But I don't want to spread any negativity on that, but I think really what we're trying to get to is who is the most informed to state when some configuration of software, some application, et cetera, is going to be the kind of the validator against a control, the ways with which we can prove out that yes, for this control, we're really trying to get to how secure is it and how does it comply with controls. And really we got to lean into open source and lean into the software providers, even closed source, providing us with data that we can, not only process, but we can go and then validate and build automation for validating. And that's going to be, kind of crucial in that continuous compliance adoption. And I'd almost say real-time identification of threats are almost two in the same. We can identify in real time when something has become non-compliant, and this is especially useful. You want to be aware of this constantly, continuously, but also we want to lean into that as part of tool stacks that can provide us with this information. If you listen to some of the previous talks just today, they've mentioned, hey, like we have APIs for everything, and we should use those APIs to go and get information. We also get and build upon compliance with those same APIs. And in doing so, something becoming non-compliant may be an indicator that there is something suspicious going on, that there's a vulnerability present, that there's a threat actively being executed against your environment. And so these are, again, they need to coincide with one another, and they need to work with one another in order to really build out those systems. And so, again, high level, if we're just thinking about how does anybody add value to this this process, we want to walk through kind of like some quick ways to start looking at how you've done some compliance activities in the past and start to say, okay, well, is there something that I can automate here? And so we lean into kind of these 4 steps. I'm going to say they're just kind of generic and, again, high level. We want to identify what we've done. How have we done it? What have we said was compliant and how a control was validated? And then start to dig into it, start to take one of those. Again, if only one control gets automated now, and we can continually reproduce how it gets validated, then we have one. And now the next time that we have the ability to keep building upon that, we can build this stack of different ways to get to continuous compliance, to get to authority to operate faster. And so we identify what we've done previously. How have we said that a control is validated? We can start reproducing that, right? Am I able to go and check something? Am I able to access an API and say, what information do I need to, in order to prove out compliance? Can I automate that? Can I run that, even if it's just periodically, right? Even if it's every night, if it's every week, something gets us moving in this, space forward. We make progress and we start to say, okay, well, if I can prove out like, okay, it needs to return this set of information every time. And if it doesn't, then maybe that's an indicator that I need to look at either the fidelity of my automation or that the compliance for my system may very well have changed. And then start to validate. And this needs to be a continuous process. It needs to be like a continual workflow for, building out validation. And optimally, we want these documents and for software and different pieces that we are components of a greater system. We want those to live somewhere that we can iterate on them. So open source is going to be ripe for kind of this implementation, because that data, that information can live in the open source. It can be continually validated by those who have a very high compliance background, for those who have a security background, and we can continue to collaborate with one another and build out like high fidelity validation, which will be super important as we get to continuous compliance. And I haven't really mentioned OSCAL a lot yet, just here and there, but really OSCAL is going to be the crucial in all steps of this process for providing a standard way of talking, right? It's the grammar, and it's the way with which we can start to model out what does this look like, where does it come from, how does it interact with different things. And so the introduction of machine readable OSCAL, lets us start to build out that real-time validation. We can take a environment that has nothing in it, it's completely bare, and from there start to assimilate tools and configure them, and go from nothing in this bare environment to an environment that has like real-time visualization of not only what's running there. We have all these tools out there that can do a lot of observability, security, container runtime security, et cetera, but also taking that a step further and saying like, okay, well, what's our compliance look like within that? And we can leverage that, every day in order to kind of provide this defense in depth for our runtime, our policy enforcement, for our compliance of our system, and when configuration has drifted. And so I'm going to call out an example. Again, I'm not trying to sell products. I'm not trying to sell any one thing, but I want to call out something that we were experimenting with to try and just put thoughts on paper and prove out a workflow, prove out that previous 4-step workflow. And so we've got Lula Defense Unicorns open source project for kind of taking a look at this and abstracting like how do we get meaningful data on compliance from Kubernetes at the moment back to the hands of those who are building out the system, those platform engineers, the operators, the SREs of the environment, and ultimately get back all data, meaningful data, all the way back to those who are in a seat to say, yes, this environment is approved to operate. And so with Lula, again, we're using it as a case study here. We can start to walk through the process. And really what this looked like for us when we were proving out this theory was, we know Kubernetes, we've sat through, discussions on containers and Kubernetes today, but we know that it's a declarative system, and based upon, the cross section of things like GitOps, DevSecOps platforms, and the declarative nature of how Kubernetes runs, that we are declaring the configuration that we expect to be present, and anything within that we can start to say, well, based upon the configuration, configuration of this live system, mind you, let's check and make sure that it's in the correct configuration. And if it is, it may very well be compliant with a number of controls. And so we can reproduce that, right? We can query the Kubernetes API and say, I know what I deployed. I know what configuration it should be in. And so when somebody does some imperative action to try and, gain access to my system or some other malicious activity, and it changes that configuration, that's, going to make me non-compliant, but also I can be aware of that. And so we knew where to look for the data. We knew how to reproduce it, because it's all that configuration data is in the Kubernetes API. And we started automating, right? We said, okay, here's some OSCAL data, and it contains the control mapping for my Istio service mesh. And based upon that, I can go and at any point in time or in real time continuously I can go and check that and then move on to the validation. If I know where to look for that data, because we do, and we know what configuration it needs to be in order to be compliant, we can start validating that. And we say, okay, this control required Istio to be configured in this way, and I need to validate that that is the case. And if that strays at any point in time, then I'm no longer compliant. Something is wrong. I need to look at my system, other security measures, etc. And we can continue to, again, iterate on this. How do we get to a point where the validation is very, the fidelity is very high, and that you should be able to have great assurance that that environment, that configuration, those controls are satisfied. And just to kind of pull out some fun here, we've got this quick demo for looking at a live Kubernetes environment. I'm going to go through it with you. Really, we've got a live cluster here, nothing too crazy about it. We're using Zarf to orchestrate some of our workload deployments. I'm going to deploy a workload here. It's going to run through and it's going to create a test workload. And so we'll look for pods in our cluster again. And what we'll see is at the bottom there, you see a workload -hash running with 2 of 2 containers in the pod. We'll now use Lula to query the Kubernetes API using that component definition, and we get a status passing. That's kind of our mock at the moment for, hey, like this is compliant and this is good. And then we can also test out like, hey, like this is actually doing compliance against this configuration. So we redeploy a workload in a non-compliant configuration. You'll note the workload is now only has 1 of 1 containers in the pod. It's missing something that it needs in order to be compliant. And then we'll rerun Lula and just kind of say, like, note here, like what happened. And we're just comparing the 2 things. This compliance information from OSCAL was ingested, and the output of that was kind of the compliance based upon the live configuration as it exists in the cluster. We're not talking about static paper manifests only. We can do a lot of manifest related work, which is still on the table, but we want to acknowledge that the live environment is the most important thing. And so with that, that's kind of Lula as my example, and I don't want to take up too much more time so we can get a couple questions in, but highlight the NIST mini workshops, highlight a lot of interesting perspectives on OSCAL, use cases and solutions. So I spoke on there previously. Michaela had me on to talk about automation. There's been other vendors, other people who are doing studies with OSCAL and talking about the value. And so this is a very good place to go and look back at the previous workshops and maybe kind of stay tuned for future. So with that, Matt, I'll open the floor for questions.
Yeah, bring the question, bring the heat. We've got one here in Q&A. So this one is, where is the best place to contribute and participate? I think he's referring to your recent demo, Brandt, but I'm not sure.
Yeah, I mean, I'd say they're like twofold. One, right? Like we need people to talk about this compliance processes in somewhere. So Lula would be a place to talk about a very specific tool. NIST, OSCAL discussions, there are a number of places to go and also have those discussions, which Michaela can probably point us at links to, such as their Gitter channel and these other forums with which to have these activities. The OSCAL and Metaschema repositories are all public on GitHub as well. So there's a number of different places that people can go to get started.
Fantastic. I hope that's what you're asking. Jason, that's what I call you because that's the name you put. Any other questions? Go. We got a couple more minutes. You can just throw them in the comments. You don't have to use the Q&A and I'll ask them, or you can use the Q&A button. Michaela and Brandt, love the conversation. My favorite thing about being involved in this event is that I know very little about what you all do. So learning all of this stuff has been really valuable for me. And yes, Rob, the slides are in. We did load the slides up into the session in the lobby. So you guys can download those, access those. Oh, we got a question coming in. So I'll read it off. The question, I know there's context. The question is, how do we get them to understand the importance of this and accepting it? Coming in, oh, it's actually to Gerald. Gerald, does that include educating the stakeholders that are making decisions for programs? I feel in my experience, most of them don't understand or don't want to expect these automated tools to help programs. So the question again, how do we get them, being stakeholders, to understand the importance of compliance automation and accepting it? Michaela, Brandt? I don't know the answer.
You do? Do you want to
I
answer?
don't. No, I don't know the answer. You guys know the answer.
It takes the entire town. I don't think it's a war of one person. I think we all have to fight that together.
Yeah,
We need to modernize.
Absolutely. And to expand on what Rob was saying, right? Like, we want to start building out, collaborative efforts among industry to set the stage. And this obviously is a prime candidate for establishing that authority behind OSCAL and the use of OSCAL and whatnot. But then from there, leveraging relationships and collaboration between NIST and other entities and then end users to really build out that town, really like the town of people who are starting to further adopt this and use it extensively. And there are extensive applications, as Michaela has mentioned, but everybody's at a different point in this journey. So, there's always progress to be made.
And if we haven't convinced you yet, the benefit of investing in security automation, in particular using something like OSCAL. If you don't want OSCAL, find something else that is out there that satisfies the same requirement. If not, come back to us and we'll help you with OSCAL. If we haven't convinced you, Brad put a link to a page that takes you to the mini OSCAL workshops. And also on our website, OSCAL website, we have recordings from the past 2 years of entities around the world that are providing solutions, OSCAL-based solutions, from Europe to Australia to New Zealand to Israel and so on. reInvent, AWS, reInvent, they presented it. They are all very deep into that, and many other cloud service providers that can speak for themselves, but I can also share that information if necessary. I put several links in the chat to the page, to the OSCAL pages with the documentation, and also to GitHub, where we have the models, and GitHub repository with the content that we are maintaining. There is also a FedRAMP repository that I'll just find it in a second.
Excellent. Thank you, Michaela, and thank you, Brandt. With that, I will thank you guys for the wonderful conversation. Yes, it is wonderful, Brandt. I do say that for every session, but it's been that kind of day. It's just that's why these great speakers and you guys are all fantastic. I will throw another plug before I let them go and you all go, is please fill out this survey that I'm about to put in the chat. This helps us, this helps them. If you want them to contact you with things they're up to, there's an option to put that in the chat, in the survey there. So please help us by giving your feedback and let us know who you want to contact you, because we won't just have everyone do it. We'll make sure that you don't get spammed and get the ones that you want to get to. So thank you again, Brandt and Michaela. Wonderful conversation. Really appreciate you guys.
Awesome. Thanks, Matt.
Thank you. The last message